This video is going to show you how to calculate the limiting reagent. So in your packet, you have two different strategies for calculating limiting reagent. I'm going to demonstrate each one. I'm going to start with version A first. So in version A, what you would do is you would need to find the mole to coefficient ratio for each reagent that they give you in the problem. And then once you have those, you would circle the lower ratio because that would give you your limiting reagent. So if we look at this example problem, we have a balanced equation, and it asks how many moles of barium chloride can form if you have 35 grams of barium sulfate and 0.60 moles of HCl. Well, we already have moles of HCl, so we could make our mole to coefficient ratio. It was 0.60 moles of HCl, and the coefficient for HCl is 2. So the mole to coefficient ratio would simplify to 0.30 for HCl. The other reagent they gave to us in grams. So we're going to have to convert the grams into moles before we can make our mole to coefficient ratio. So if we need the moles of barium sulfite, we had 35 grams of barium sulfite. To get the moles, I'm going to need the molar mass. So I calculated that to be 217.39, set it up so that the grams would cancel and I'm left with moles. So if I multiply by 1, divide by 217.39, I get 0.16 moles of barium sulfite. So then if I look at the balanced equation, the coefficient's an invisible 1 there. So I'd put the ratio as 0.16 moles to 1. Well, this is the lower ratio. That means that this is going to be my limiting reagent. So then it says to scratch through these ratios. We're not actually going to use this to solve the problem, but what that tells me is that this right here is the limiting reagent that's going to tell me how much product that I'm going to make. Of this, I will have excess. So if this isn't working for you, if you don't like the ratio of moles to coefficient, the other thing you could do is just go ahead and do the stoichiometry twice and look at product. Instead of trying to predict ahead of time, you could calculate the moles of product that you could make using one reactant, and then you could go back and calculate the moles of product using the other one and circle whichever one is smaller. So if we're using that same example, we would start out trying to find out how many moles of barium chloride, since that's what it's asking, from those 35 grams of barium sulfite. So the first thing we need is to turn the barium sulfite into moles. The next thing we need to do is go to the balanced equation and make our mole ratio. So 1 mole of barium sulfite gives you 1 mole of barium chloride. So that's our mole ratio. And when we calculate that out, we would get 0.16 moles of barium chloride. Now we do the whole thing with the 0.60 moles of hydrochloric acid, trying to find out how many moles of product could I make with 0.60 moles of hydrochloric acid. I'm already in moles, so all I need here is a mole to mole ratio. Well, this time there's a coefficient in front of the HCl. There's just the invisible 1 in front of barium chloride. So the mole ratio would be 1 mole of barium chloride to 2 moles of hydrochloric acid. So if I multiply 1 and divide, I get 0.30 moles. Well, I can't make 0.30 moles if I run out as soon as I've made 0.16 moles. So this would be my limiting reagent.